Today I'll be talking about John Dalton. He was an English meteorologist and chemist. He was a pioneer and developer in the modern atomic theory. He was born in September 6, 1766, into the Quaker family. He was the youngest out of three, and he was the only one that survived as he grew up. At the age of 12, he was in grammar school, and his brother was also a teacher at a school, and his older brother made Dalton become his helper for his older brother. At the age of 15, he helped his brother run the school in the Quaker school near Kendall. When Dalton was a teacher, he looked up for two mentors that were important to him. Their names were Elihu Robinson, which had some scientific taste in Eaglefield, and John Gough, which was a mathematical and classical scholar in Kendall. These two people helped him realize the scientific things to make him interested and go into his future. He learned rudiment of mathematics, Greek, and Latin from the two mentors, and Robinson and Gough were amateur meteorologists, but Dalton gained the knowledge from them to get more knowledge for himself. For the men, Dalton have gained practical knowledge in the construction and the use of meteorologist instruments and keeping daily weather records. Dalton was very interested in the meteorological measurements for the rest of his life. This made him very interested in seeing every weather, and this led him to make a book with all the weather measurements from the meteorologist mechanism. His first book that he wrote was called The Meteorological Observation and Essay. It was published the same year, and he was going into New College in Manchester. His early scientific careers was in 1793. Dalton went to a college to teach mathematics, and he took with him his book with a collection of meteorological topics, as well as his topics of looking at the weather each day with his records in the book. As you can see, the book on the side on the right, if you're looking at the screen. This book has everything about meteorology topics based on his own observations with no help. The book that Dalton has made wasn't that famous at first, since no one really knew what meteorological things or systems were, and he was very interested, so this made him more excited to look into it. His book had more original ideas and made a transition of meteorology from the topic of folklore to a scientific pursuit. So people didn't really believe him and thought it was just a tool, but he kept it and kept going with it based on science. Dalton had various observations in the meteorological phenomena. He only looked at his views and no popular opinions, so he looked only straightforward at his own topics instead of listening to any others, and this led him to many achievements. In some of the papers, Dalton had contained his independent statement of Charles' Law, saying, "All elastic fluids expand the same quantity by heat." This helped Dalton keep going and realized that there are many things to learn. He also has clarified that the air is not a chemical solvent. Dalton had claimed that the force of repulsion thought to cause pressure acted only between atoms of the same kind, and that the atoms in the mixture were usually different in weight and difficulty. He discovered that the atmosphere was a physical mixture and was around 80% nitrogen and 20% oxygen instead of certain compounds and elements. He measured the air capacity with his meteorological tool, which was water vapor and other particle pressures with a temperature. Dalton also defined partial pressure in words of physical law. Every mixture gas lets out the same pressure is the same gas was the only one that was present. One of Dalton's peers was a British scientist named John Frederick Daniell, hailed Dalton as the father of meteorology, since he was the only one that made more scientific-based observations and has many details in his book that he made. After being in the college, Dalton was elected as a member of the Manchester Literary and Philosophical Society. The first thing he contributed to society is about his colorblindness, him and his brothers, with red and green colors, which he called Daltonism. Daltonism is for colorblind of red and green types. This name of colorblind was from the chemist and physician, of course, from John Dalton, which actually did the observation and studies. His atomic theory. With Dalton being interested in meteorology, it led him to become interested in atomic theory and the law of partial pressure. Dalton's most recognized work in history is his work in chemistry was the atomic theory, and this helped lead other chemists in the future to know about the atomic theory and elements. He didn't know where he got this theory from, but he doesn't have a recollection, but the subject was incomplete since he only thought about it and his own theory with the help of meteorological things he did in the beginning. He based his theory of partial pressure on the idea that particles like atoms in a mixture of gases repel one another, but not like atoms appear to react indifferent towards each other. What Dalton has discovered shows why each gas in mixture behaves independently. Based on different particles, they all have different ways of going around. Even though his views were later to be a mistake, it still shows a useful purpose in allowing other people to know his mistakes. People learn mistakes and gain new knowledge from their mistakes. And Dalton has done that by doing his first theory and making an observation. Dalton claimed that atoms are different elements vary in size and mass, and surely this claims to a cardinal feature of his atomic theory. Dalton believed that only that each atom had its own kind of atom. His thought process were different from other people's ideas. Some believed that there is many different particles that could destroy the accessibility of nature. Of course, Dalton didn't believe what other people believed since he had his own ideas in mind. He focused on trying to find the masses of each different kinds of mass and not following others, and this led him to know more than any other person that was scared of the particles to destroy them. Dalton claimed that considering the numbers of atoms of each element present in different chemical compounds, even though Dalton had taught chemistry for a couple of years, he had never yet performed actual research in chemistry, only all observations or the theory. In October 1803, he said that an inquiry into relative weight and the ultimate particles of body is a subject, as far as I know, entirely new. I have lately been prosecuting this inquiry with remarkable success. His experiments on weight structure of an atom. As you can see in his book, his first book, you can see that he did the atomic theory in different types of shapes and sizes with different weights. Dalton calculated atom weight from percentage to the compound by using an arbitrary system to deciding the likely atomic structure of each compound. For example, if there are two elements that can be combined, their combination will occur in a set sequence. He had said about measuring the masses of many elements, as well as hydrogen, carbon, oxygen, carbon, and nitrogen, based on what way they combined with mixing with fixed masses of one another. If the measurements were to be meaningful, the elements had to be combined in a mixed proportion. Well, Dalton took this as for granted and disregarded between the French chemists. He didn't listen to the French chemist since he wants to know his own way of thinking and his own way of experimenting his atoms. Dalton measurements were unworked as they were made him formulate the law of multiple proportions. This is when two elements form more than one compound, having the mass of one element that combines with the fixed mass of the other ratio of a small whole number. This then can be taken the element as A and B, the different combination between naturally occurring to the massive ratios of A, B. The principles of Dalton's law can be demonstrated using a simple experiment that involves a glass bottle, a large bowl of water. When a bottle is underwater, the water contained is displaced, and when the bottle is now empty, it contains gas hydrogen that cannot be seen. Dalton's law primarily applies to ideal gases rather than the real gases, since he only observes things and thinks with his theory due to the elasticity and low particle volume of molecules in the ideal gases. There are amounts of pressure that exerts by the hydrogen that can be identified using the chart that lists the pressure of water vapors at different temperatures, all thanks to Dalton's discovery. As the Swedish chemist John Jacob Berzelius wrote to Dalton, the law of multiple proportion is a mystery without the atomic theory. Dalton had provided the basis of the theory. Dalton has only found out what is on the surface, and more people in the future will find things deeper and deeper. Dalton's theory examines the composition of compounds, saying that the tiny particles like atoms in a compound were compound atoms. In 1810, Dalton had published his second book, A New System of Chemical Philosophy. In the end, he had composed a table listing the atomic weight of all the elements. On his later years, at the age of 50, Dalton only performed little scientific work, since he didn't have that much more of an idea since he was thinking of all his ideas in the past. He still works on different fields, which shows that he's still interested in scientific fields. His atomic theory eventually began to prove its worth, and had become famous in being known around chemist people. Dalton was elected into the Royal Society of London and was awarded with an honorary degree. In 1833, the government granted him a pension, which was given again in another time at 1836. This degree was offered from the Doctorate of Law by the Edinburgh University in 1834. He continued to teach people and had kept his reputation as a devout Quaker, but he only taught people in private as his little pupils, since he didn't want to become famous, and people thought he was awkward when he was doing his speech in other college teaching classes. Dalton have lived a respectful life with no problems, never married, and was a stress-free life. Still having the interest of and fascination of science and still in his mind. In 1837, Dalton had a stroke. This made him have a problem with his speech for the next year. After Dalton had a second stroke, Dalton died on the evening in July 26, 1844, at his home in Manchester, England, where he was in the beginning when he was little. He was provided with a civic funeral and granted full honor. He died in a peaceful way, quietly, but with a stroke. He had found a way to, as he died, in the future it keeps going. He has found the atoms, and this made chemistry known to be studied more and more throughout the years. That's it.